What is positive train control? What is positive train control? The PTC law is not a technical standard. There is no PTC system as such, says Pierre-Damien Jourdain, Solutions Director for Alstom Signaling. In fact, several systems do qualify under the safety law, including Siemens CBTC, GE Transportation's incremental train control system in operation on high-speed Amtrak lines in Michigan and Illinois, and Alstom's advanced civil speed enforcement system. Alstom and Amtrak collaborated to create the system that has helped the passenger railroad successfully avoid crashes on the Northeast Corridor since 2000. Among the alphabet soup of options, all PTC is, says Jourdain, is another phrase for automatic train protection, which has been in use in railroading for decades. According to the Safety Act, any of these systems must do four things: prevent train-to-train crashes, enforce speed limits, protect track workers, and keep trains from running through a misaligned switch. This is why classes didn't consider the system Alstom developed for Amtrak. It uses fixed location transponders embedded in the tracks to locate trains. In dense urban areas with hundreds of commuter trains a day and set track alignments, predictably spaced, hardwired beacons could stay in place for years of service. But in mountainous or remote areas of the country where trains are few and the population is sparse, the costs for frequently placed transponders, wiring, and corresponding maintenance would be great. Instead, railroads chose to anchor their system on the widely available global positioning system to locate engines. Today, Wabtec offers IETMS, or Interoperable ETMS. Union Pacific, BNSF, CSX Transportation, and Norfolk Southern have all said in interviews with trains that they intend to use Wabtec's system to comply with the Safety Act. The system shares features and is designed to be interoperable with other companies' PTC applications but functions on Wabtec's own software. One of the other benefits we hope to achieve in leveraging this investment in PTC is integration with our other energy management systems to further improve our fuel efficiency, says Chris Matthews, BNSF's Assistant Vice President for Network Control Systems. As this gives us more precise location information for our trains, we're incorporating that into our movement planning with the goal of increasing velocity. Using that position information and local conditions reported by wayside units and dispatchers, computers built into locomotives will constantly recalculate when a train must slow down and stop relative to wayside signals and digitized track warrants. The system will automatically apply the train's brakes and cut engine power if the engineer fails to do so. Train and back-office computers, meanwhile, maintain speed restriction information for curves, speed limits for operating through switches and crossovers, as well as variable information from train consists and track conditions, and local notices from maintenance of way crews. The capability prevents trains from running too fast for a given area, even if a train is operating at less than a local speed limit. And for misaligned turnouts, the system detects what position a switch is in, governing train movements more effectively than older track circuit technology. Wabtec's system will comply with required event recording rules so every engine control, signal aspect, and piece of data used by the train crew and locomotive are stored in case of an accident. Then there is the widely discussed, interoperability component of the Rail Safety Act. It requires railroads to install systems that enable trains to continue interchanging with other railroads without delay. It is a complication that makes reliability even more difficult to achieve. In much of the rest of the country, where GPS-based PTC systems are expected to dominate, the focus is on how systems will automatically work together without extra equipment. CSX Transportation's PTC Director, Kenneth Lewis, calls those tasks communications and functional interoperability. They are difficult to accomplish, Lewis says, because when PTC systems first came on the market, they weren't interoperable at all. Rather than trying to squeeze the PTC systems to meet a new requirement, they were redesigned from scratch to accommodate the 2008 mandate. A CSX locomotive has to behave like an NS locomotive when it's on NS property and vice versa, Lewis says. We all need to talk in the same message formats and use the same communications language and the same radio frequencies. Standards for the railroad systems to speak with one another are set by the Interoperable Train Control Committee, with the Association of American Railroads as a facilitator. Specific protocols are available from the AAR, for a fee, to the public and to potential vendors. Positive train control, in its various forms, does work and will keep improving in the U.S., making railroading safer than ever. The question is whether railroads can move fast enough to satisfy Washington and the public while figuring out how PTC will make sense from a business viewpoint. Thanks for watching. Follow on Twitter at McKenney Brief.